tensile test.
Okay, today I'm going to talk about the additional theory. The strain, which is the elongation of the sample, is defined as uh, elongation over original length, which is delta L over L naught. The stress, which is the applied force divided by the original cross-sectional area, is defined as force over cross-sectional area is equal to force over A naught. Okay, during the elastic deformation, the relationship between stress and strain is linear. All the deformation in terms of elongation can return to its original length upon the removal of strength on that specimen. Beyond the yield point, any further induced stress in the specimen will result plastic deformation. A yield point has yield strength of material which is defined the maximum stress of a specimen can sustain without suffering any plastic deformation. In this experiment, since the graph produced by the testing machine shows for both mild and aluminum specimen without a clear yield point like the structural steel. Therefore, steel value called offset yield stress is used to estimate the yield stress for the both specimen. The offset yield stress is defined by first drawing the straight line to the best fit the data initial, which is linear portion of the stress strain diagram. Second one is the second line is drawn parallel to the original line by offset by 0.01 amount of strain. The third one is the intersection of this second line with stress strain curve determine offset yield stress. Lastly, ductility is the one of the important property to be determined in tensile test. It is defined as the ability of a material undergo permanent deformation through elongation and reduction in cross-sectional area at room temperature without fracture. The percentage of elongation can be calculated as LF minus L naught over L naught times 100%, where LF is gauge length measured after fracture, L naught is gauge length measured before the tensile test. The specimen elongates during tensile test. It will experience reduction in cross-sectional area. The percentage reduction area is calculated as A naught minus AF over A naught times 100%, where A naught is cross-sectional area measured after fracture of the specimen, while AF is cross-sectional area measured before tensile test. In short, the greater the percentage of reduction area of a specimen, the higher the ductility of the specimen. That's all. Thank you.
Assalamualaikum. My name is Fakhrul Azwan bin Muhammad Noor. I want to present about the result. Firstly, for aluminium, it has an average diameter of 7.9. For mild steel is 8.02. For the gauge length, aluminium has average 86.09, while the mild steel has 87.01. For mild steel, 10 value of applied force and elongation were taken along the applied force versus elongation curve and recorded in this table below. Applied force versus elongation, while stress versus strain. For the graph and strain for mild steel specimen is 554.20 megapascal. For aluminium, also has applied force and elongation, stress versus strain. It has 214.21 megapascal for the stress, while 0.021 for the strain. Thank you.
Assalamualaikum. I'm Shaheefa. So for the observation for the experiment, both mild steel and aluminium specimen were being put at a constant rate of 5.35 mm per second downwards. When the specimen were pulled by testing machine, the thickness of the specimen would decrease slowly. The time taken for my steel to reach fracture was longer than aluminium. The my steel specimen was fractured at the middle of the gap length, whereas aluminium specimen was fractured nearby the upper end of the shoulder, where the grip section was held stationary. At the initial portion of the test board, the my steel and aluminium specimen showed a linear relationship between applied force and the elongation of the specimen. The gauge length of aluminium specimens was shorter than my steel specimen before the tensile test. The gauge length of aluminium specimen showed the typical standstill behavior for metal from graph generated from the testing machine.
My name is Muhammad Yazid. Now, I will explain about the calculation for the tensile test. First, we need to calculate the Young modulus from the graph stress versus strain, the percentage reduction of area, and the percentage of elongation. For the mild steel, the stress from the graph that we got is 554.27 MPa and the strain is 0.037. For the Young modulus that we got is 14.98 GPa. As for the percentage of area, we use AI minus AF over AI times 100%. We use AI 50.517 mm squared and AF that we use is 28.653 mm squared. The percentage that we got is 43.28%. For the elongation, we use LF minus LI over LI times 100%, where LI is 87.01 mm and LF is 93.28 mm. The percentage that we got is 7.21%. As for the aluminium, the Young modulus that we got is 10.20 GPa, while the percentage reduction of area for aluminium is 54.14%. Lastly, the percentage of elongation for aluminium is 13.02%.
Hello, I want to talk about the discussion for tensile test. Young modulus for mild steel is 14.98 megapascal, while for the aluminum is 10.2 gigapascal. The yield strength for the mild steel is 640 megapascal. For the aluminium is 230 megapascal. Ultimate tensile strength is the 680 megapascal. For aluminium is 310 megapascal. The highest strength for the mild steel before necking. The systematic errors occurs when the calibration of the measuring device is not correct. Random error, parallax error, which is eye vision not perpendicular to the scale of the vernier calipers. That's all from me. Thank you.
So, the conclusion for this experiment: many engineering applications that require high textile strength equally utilize my steel. This is the result of the crystalline structure of my steel that permits it is withstand high pivotal loads before break can happen. Aluminium anyway can discover numerous utilization in structure that require low thickness material like in aerodynamic and some motor vehicles. Aluminium encounter high ductility with construct with my steel and have long disline low level estimate of Young modulus, a factor that determines deflection in structural component. This experiment consequently investigate close relationship of textile strength of the theoretical data.